Section 2 of Chapter 2 works with more derivatives, and today we pick up some shortcuts of how to take derivatives. So primarily we're going to be working on the power rule. But before we get that started, it is essential that you understand how to work with rational exponents. So if I look at this square root of x, I could rewrite this as x to the 1/2 power. If you recall, if I have a square root, I could have a q value here inside the index of the radical, and then I could have x raised to some p or power. That translates into x to the p over q, power over index. So on this next one, square root of x to the 5th, 5 is my power, and then a 2 here is the q value, so I get x to the 5/2. This one here would be z. It has a power of 1, and then an index of 4, so z to the 1/4. Here, let's rewrite. Let's bring that negative exponent up to the top, and 2x to the 7th looks like a good representation. And on this one, I could rewrite this as x to the power of 3. Index was a 5. It's the 5th root. And since it was down below in the denominator, that'll be a negative 3/5. The constant rule. So if I'm going to take the derivative of a constant, like f of x equals c or y equals c, the derivative of that would be 0. And I can find that, I can prove that if I use the limit definition for derivative, and I take and plug in x plus h everywhere I see an x, but wait a minute, there is no x, so this will just be the function c when I evaluate the function at x plus h. And then I subtract the function f of x, which is c as well, and c minus c is 0 divided by some value as h goes to 0. So 0 divided by a number ends up being 0. The derivative of a constant is 0. So if I look at this function, here's an example, y equals 9, its derivative is 0. You know that graphs out as a horizontal line at a height of 9, y equals 9. And just looking at this function, you can see that its slope is 0. Well, we're using derivatives to show the slope at any particular point along this line, and that would be 0. So here's a list of rules that we'll run through real quick, and we're going to utilize them today as we do other problems. The constant rule, we just talked about, the derivative constant is 0. And you can think of it as y equals c as a horizontal line that has a slope of 0. Linear functions, where I have x to the 1st power, and maybe I have a coefficient such as m in front of it, well, the derivative will be m. And we've recognized, or maybe you do recognize, that this is a linear function, like we could have y equals mx plus b. If I let b equal 0, then I'm just at mx. And that would mean that the slope is m. So it makes sense that the derivative is m. Here, the derivative of x to the n, this is called the power rule. N comes down in front, and I get x raised to the n minus 1. I reduce the power by 1 degree. Some are different. The derivative of two functions here, f and g, can be split up so that we take the derivative of the first one and add it to the derivative of the second one. If the case was that it was subtraction, then I would just subtract the second derivative of g, the second function's derivative from the first function's derivative. And the constant multiplier, I will just take c times the derivative of the function. Here at the bottom, we pick up a couple trig functions. The derivative of sine is cosine of x, and the derivative of cosine x is negative sine of x. Power rules. Now let's practice a few of these. So here's my function. It has a multiplier in front of it, so I'm going to take the derivative of it and multiply it by 5. So it'll be 5 times. In order to do the derivative of x to the 6th, I use the power rule. 6 comes down. I make this x to the 6 minus 1. I reduce by a degree 1. And now I can write this as 30x to the 5th. On the second example, I've got a power rule in this first grouping and then also another power rule. This is the example where I have two functions added together, and I'm going to take the derivative of each function separately. So f prime of x shows a derivative. That derivative is equal to my 5 power is going to come and multiply by that negative 7. And then I've got to reduce 5 by a power of 1. I'll come back and clean it up in a bit. I have 1/2 my multiplier. It's going to get multiplied by 4, the power coming down from the power rule, x to the 4 minus 3. So let's simplify this. F prime of x is equal to negative 7 times 5 is negative 35, x to the 4th. Half of 4 is 2, x to the 1st. How did I get a 3 there? 4 minus 1, and it gives us 3. I think I was thinking of the result earlier, because we just reduced by 1 power. I have a negative exponent, but that's not going to be a problem. I still just use the power rule, and the power rule says bring the power down in front, so I'm going to have y prime to show that this is the derivative. 8 times that negative 3 coming down, x raised to the negative 3, reduce it by 1. Let's simplify. That makes y prime equal to negative 24, x to the negative 4. Well, if we don't want to leave a negative exponent, we could drop it down below and write it as a positive 4. That would be a preferred result there at the end. Another negative exponent, but it really is treated no differently, right? We just bring the power down. I'm going to have 3/8 times negative 4, and then x to the negative 4 minus 1. Let's rewrite that, simplifying what we can. That'll be negative 12/8, and 4 will go into, well, I'll just write it, negative 12/8, x to the negative 5, and now let's simplify. G prime of x, 4 will go into each of these, so I get 3/2. That'll be negative 3 over 2. And this x to the negative 5th I can drop into the denominator and write it as a positive 5 exponent. A few more to practice. F of x equals x. Well, this has an invisible power. We know that understood power is 1. So using the power rule, I would get that 1 comes down, x goes to 1 minus 1. And that's going to make this f prime of x equals 1, x to the 0. But anything raised to the 0 turns out to be 1. So I ended up with 1 times 1, which is 1. This next one, the g of x function equaling pi, this is a tricky one. Because what is pi? Well, pi is about 3.14. Oh, you mean to tell me that pi is just a number? Yes. So I'm taking the derivative of a constant. G prime of x will turn out to be 0. This is the derivative of a constant, so follow that constant rule, which says the derivative is 0. All right. For this one, I think what I'll do is just follow the power rule. I'll have f of x is equal to, square root 2 is going to come down. I know it's a goofy power, but it'll be fine. And then I can say I have x raised to the square root 2 minus 1. Now, if I could do any simplifying here, I would, but those two are unlike terms and they will not come together unlike numbers. All right, a little practice with those trig functions. So I have f prime of x is equal to, this multiplier will still be a multiplier, and the derivative of sine changes to cosine of x. There's my answer. I have two functions here. I'll take each derivative separately. G prime of x is equal to, the derivative of cosine is negative sine of x. Just memorize it. And the derivative of sine, well, 8's my multiplier. It'll stay there. The derivative of sine is cosine x. There's our answer. Sometimes you get into problems where it looks really complicated, and you might be better off rewriting it. For instance, this x squared that's down in the denominator, I think I want to rewrite that as a negative exponent. So first off, I'm not doing the derivative. I'm simply working with the original function f of x. Negative 2/3 is a multiplier, so I'll have negative 2/3 and then x to the negative 2, bringing this term back up to the top using a negative exponent. Now we're ready to use the power rule. So we'll use the power rule to take the derivative. F prime of x now, because we are doing the derivative. Negative 2 will come down and multiply this. So I'll have negative 2 times negative 2. Oh, that was negative 2/3 in the front. Negative 2/3 times negative 2. X to the negative 2 minus 1. And we have a space here where we can actually simplify this. And that will be negative 2 times negative 2 is 4/3. X to the negative 3, so it'll drop to the bottom as x to the 3rd. The next example, I have the bottom 4x being cubed. All of that in the parentheses needs to be cubed. So let's kind of use that distributive idea of cubing this out, and I'll have f of x is equal to pi over 4 cubed x cubed. Still staying with the original function, I'm not doing a derivative yet. I would have pi over 4 cubed is 64. And then let's write that x cubed as x to the negative 3 since it was in the denominator. We are now ready to apply the power rule. And the power rule says bring the power down. So I'm going to have f prime of x, because I am doing a derivative, negative 3 pi divided by 64. X to the negative 3 minus 1 makes it x to the negative 4. And I would like to format my answer by bringing that x to the bottom as x to the positive 4. This one, it is with a negative exponent. Let's rewrite that. We'll have f of x equals 4 times x to the positive 3. In order to bring this upstairs into the numerator, I will use the negative power to move me up. This is ready to be used. Using the power rule, we can take the derivative. 3 times 4 is 12, and then reduce the power of 3 by 1, and we're at 12x squared. This last one is a doozy. Let's rewrite. Of course, we've got an index of 2, and this is our power, isn't it? There's the power. 2 is our index of our radical. So let's just rewrite the function f of x is equal to x raised to the 2 plus pi divided by 2. That could be simplified. We could write this as f of x equals x to the 2 over 2 plus pi over 2. That's an f of x equals x to the first plus pi over 2. You'll see why I like that in a moment. Let's use the power rule to take the derivative. So we're going to have f prime of x is equal to, well, this is the entire power. It's going to come down. I'm going to have a multiplier. I need parentheses, 1 plus pi over 2 times x raised to the 1 plus pi over 2, reduce the power by 1 because we're using the power rule. That makes our answer f prime of x equals 1 plus pi over 2 times x to the 1 minus 1 up there gives us 0, so it's just going to be a pi over 2. I told you that was a challenging one. Okay, day 2, I will go ahead and make a separate video for it. So that kind of concludes day 1, where we just really looked at the power rule.